welcome to lecture. Um, in this lecture, we're going to talk about control. Now, Scott says I have control issues when it comes to running this course, but we're not going to talk about that kind of control. We're going to talk about the kind of control you need whenever you want to play Pong, when you want to control the position of your paddle on the screen. In the second lecture this week, Scott talked about using keyboard input to control the position of a circle on the canvas. We're going to go back and revisit that example. And I'm going to talk about a way you can change the scheme for controlling the position of the ball, where instead of controlling the position directly, you're actually controlling the velocity of how the ball moves around on the canvas. And we'll talk a little bit in OneNote, and then we'll go and I'll actually just walk you through a second example that'll actually have a lot of similar functionality to that which you'll need inside Pong. So let's pay attention to this lecture. I don't want you to have control issues now. So let's look at Scott's example of controlling the position of a circle on the canvas using the arrow keys. So let's just run the application to start. So here we have our canvas, and we've got a white circle in the middle. And I'm going to go through and I'm going to just, you can hear me, I'm going to just start banging the arrow keys here. And I'm slowly moving the circle to the left. I can go back and bang the right arrow key. You can actually see there in the status area the fact I'm continually hitting the arrow key. I can go up. I can go around in a kind of a rectangle. And you can see over here actually I'm printing out the position so you can kind of keep track of this to see that I'm really just mashing the keys a lot. Now, if you're an arcane mage in World of Warcraft where button mashing is your main skill, okay, maybe this is a good control scheme for you. But in general, if I want the circle to go up, I should probably just hit a key once and it starts moving up, and then maybe if I hit it again it stops, or I release the key, it stops, or something like that. That's what you see in most games. So this is not a great way to control the position of this circle. Let's take a quick peek at the code to see kind of what the meat of the code was that Scott used here. So what did we have? Well, we had kind of one critical variable here. It was the ball position. It was a global. And in our key down handler, we simply checked to see if we'd hit an arrow key. And if we did, depending on which arrow key is, we changed one of the components of this ball position. And we changed it by some step size. We've actually moved it 4 pixels. So every time I hit the key, left key, the horizontal component of the ball position was decreased by 4. And so essentially just I mashed the key a lot, the key handler got called a lot, and I changed the position of the ball. Another thing to note here is that I didn't do anything interesting in the draw handler. The draw handler just sat there. It was just drawing the ball over and over. So what I'm going to do is I'm going to try to go back now and revisit how we did this ball physics example and show you a different way to control the position of the ball. So let's pop into OneNote real quick and I'll outline what I'm going to do. And then we'll go back and we'll kind of look at a modified version of this. All right, let's think about the code we just took a look at and see if we can improve the manner in which we move the ball around on the canvas. So the critical thing here was that the ball had a center P here. So we're going to control the position of that point P. So this was a positional control scheme we look at. And there were some critical things that we noted. There was no update in the draw handler. So the only place that we modified things were inside the key handler. So in the key handler, if you recall, we updated this position P. It was a global variable. If we hit the left arrow, we took the horizontal component and we decreased it. Okay, that's what this equation says here. We hit the right arrow, we took the horizontal component, we increased it. And the same thing for up and down. So that's why if we wanted to move the ball a lot, we had to hit the keys a lot. So what I want to do is I'm going to think about how we might be able to modify this using some of the ideas we saw from the ball physics example to build a better control scheme. So the critical thing here is, again, we have P. Okay, that's the center of the ball. But we also have V here. What's V going to be? V is the velocity. Okay, so it's going to be how fast the circle is actually moving. So we're going to use an update that's exactly like what we saw in the ball physics example. We're going to continually take the center of the circle's position, and we're going to update it based on a velocity vector. So now what's going to happen when we hit a key? When we hit a key, we're going to control the contents of that velocity vector. So down here, now when you hit your keys, what will happen is that velocity vector will be changed. You maybe, for example, will start out with the velocity vector to be 0 in both components. And if we hit a left arrow key, what are we going to do? We're going to take that horizontal component, the first component, and we're going to decrease it a little bit. Now as you run the update loop, the ball's position will start to be updated so it moves toward the left-hand side of the canvas. If we hit the right arrow key then, well, we'll kind of cancel that out and the ball will come back to rest. Hit the right arrow key again, the ball will start moving to the right, and so forth. Now this is not exactly the way Pong works. Pong's going to work a little differently. It's going to work where if you hit a key and hold it down, your paddle will start to move. When you let the key up, your paddle will stop moving. But this kind of gives you a feel for kind of the trend you're going to have to go to actually implement Pong. So let's take what I've shown you here now and we'll look at the code that actually implements it, and then we'll play around with it for a second. All right, I've gone through and I've implemented the ideas we talked about just a second ago inside the inside Code Sculptor. So let's just kind of walk through what that code would look like. So the first thing to notice here is that now we have both a position and a velocity. They're global variables. We're going to have both our draw handler and our key handler are going to update those. Probably the thing that's most different is we actually have an update now inside the draw handler where we're going to continually update the position of the ball based on its velocity. Since the velocity starts out to be 0, no big deal, the ball's not going to move. But to make the ball move, what we're going to do is we're now going to modify the key handler so that instead of trying to change the position of the ball, we're going to change the velocity vector associated with the ball. So for example, if I hit a left arrow key, we're going to make the velocity vector have a component in the left direction on the canvas. And we can go through and hit the left key multiple times. We can make it move faster. We can hit the right arrow key, slow it down, in fact, get it moving right. So let's just do a quick demo here and you kind of see how this works. So here we are, ball sitting in the middle of the screen. I'm going to hit the left arrow key once. Ball starts moving left. Not hitting any keys, so here's my hand. Hit right, stopped, no keys now. Now I'm going to hit the right key again. Hit it twice. Ball's moving faster, stop, it's fine. You notice I can get it moving pretty faster. In fact, there's kind of a game here that you can play where you're kind of bouncing the ball back and forth. If you want to look here, you can see over behind, I'm actually printing out both the position and the velocity vector here. So you can see how the velocity vector is being changed as I hit the left and right arrow keys. Now here's a little interesting challenge. This will show why this control scheme is not the one that you see in most games. You remember before when I was doing positional control, I can make the ball kind of go in a rectangle. So let's see if I can get the ball going really fast in kind of a circular motion here. This takes a fair bit of skill. Let's see. Okay. Oh, dang. Oh, no. Oh, all right, there we go. All right, you can see that the problem is, I think that might be it. Okay, I'm going to stop ahead here. The problem you can see is as I'm trying to get the ball really fast here, that as I hit the keys, the keystrokes start to add up, and I can get the velocity vector moving faster than what I can keep on the screen. So this is not the kind of control scheme that most games use. In fact, it's not going to be the kind of control scheme you're going to want to use in Pong. There's a simpler, safer scheme that you can use, which is if you hold down a key, you increment the corresponding component of the velocity vector. When you release the key, when there's a key up event, then you decrement the same component of the velocity vector. This has the property that you can't really kind of build up multiple key presses in one direction. And that limits the velocity of the object on the screen. That's the model that you're going to use inside Pong. Okay, John's going to do his programming tips video, and then I'll be back and we'll talk about Pong more. Just take a little look at this, play around with it, modify it. I think this will kind of get you going and figuring out how to control the paddles in Pong.